So let's take a real world example here, and let's do an example of linear search, the time complexity of linear search using a 1D array. And so this is a 1D array, and if you're not familiar, the way it works is we have 9 elements. This is the first element, is the integer 40, 55, 63, and so on as we work our way down. This entire array has a name, right? And let's assume the name is ARR, R, right? And so in order to access the different elements, we need to have indices. And so that's what we do have, right? So the indices, as computer scientists usually do, start counting at 0. This is the 0 element, the 1 element, the 2 element, up to the 8th element. So if I wanted to go ahead and print out the 68, right, then I would print out arg, the name of this array, sub 5, right, the indice. So what does the indice do? It allows you to uniquely identify each element in an array. Okay. So let's go ahead and run a linear search, and let's assume we want to look for the number 68. And if we do find the 68, we want to perform an action, like let's say we want to print it out to the screen. So how do we do that? We would take a look at the first element, and we would check, is arg sub 0 equal to 68? Right? And what is arg sub 0? It's 40. And so that's not true, it's not 68. And then we want to look at the next one then, right? So arg sub 1, is that equal to 68? No. Is arg sub 2 equal to 68? Arg sub 3, 4, 5. And then when we get here to 5, well, yeah, our arg sub 5 is equal to 68. So let's go ahead and print that out. Print out 68. And then we're going to go ahead and look at 6 and 7 and 8. Those are all not equal to 68. So when we go, we're not going to go ahead and print out. So that's the algorithm. And now what I want you to do is think about what time complexity does that algorithm have, right? Is it n squared? Is it n log n? Is it n? Is it log n? Right? What is the time complexity? And so let's go ahead and take a look at the code for that. And if we look right here, this is the linear search algorithm coded in Python. And so for those of you who don't have a background in Python, these here are function definitions. This is the function definition called search. This is the function definition called main. And this is a function call. Okay. And so the way that the program runs is you run it and it ignores function definitions. Right? It ignores them, does not run them because until you call it. Right? If I call it, then it will go there and it will run that block of code. So we run the program, it goes to line 1, 2, 3, 4, 5, 6, 7, 8, up to 14, ignoring all of those lines. We get down to line 15, and this is the function call to main. So it's going to go ahead and jump up to line 10. Say, hey, I found the function, it's right here, and it's going to run its body. And we can tell that this is the body because it's indented 1 tab. Right. And so it's going to run the main function, and when it runs the main function, what is happening here is it's creating an array called arg, and it's placing those values into the array. So you can see here that each of these are going to be indexed. We don't see the indices, but they're assumed. This is indexed as 0, 1, 2, up to 9, and there are 10 elements in the array. All right, great. So we have our array that we're going to work with. N is equal to 10. There are 10 elements we're going to consider. And then it's going to go to line 12, nothing there. Line 13, and on line 13 there is a function called to search. And when it sees the function called to search, it's going to go ahead and jump up to line 4. And then it's going to run the search function. When the search function ends, it's going to come back to our search what's called. And that's the end of the main function definition, which means it's going to go back to where main was called, where it goes to line 16, and that's the end of the program, right? And so these here that's inside of the parentheses, those are called arguments, and that is the information that we're going to be giving to the search function. Right? So we can see here when we run the search function, we're going to give it this array, and we're also going to give it the number 5. Okay, the array is the array that we're searching through. The number 5 is the number that we're looking for in that array. Okay, so when it goes and finds the function called to search, it's going to jump up here to line 4. In an array, arg is going to be equal to this array that we gave to the search function, and search is going to be equal to 5. Okay, so it's going to come into this for loop, And if I haven't mentioned it before, arrays and for loops are best friends. And why are they best friends? Because this I variable in the for loop iterates, right? Meaning it starts at 0 and it increases by 1 every time the body of the for loop is run. So it runs the body, I increments to 1, it runs the body, I increments to 2. It keeps doing that until I is equal to 10. And when it's equal to this number here, it's going to break out of this for loop, stop looping, which is going to be the end of the search function, which is going to come back down here to line 13, which is going to be the end of the main function. It's going to come here to where main was called and go to line 16, and it's going to end our program. Alright, so why are for loops and arrays best friends? It's because you can see here that if you say arg sub I, this is the way we say sub with the 2 brackets, arg sub I, the first iteration of this for loop is going to consider arg sub 0, which is this guy. Then it's going to consider arg sub 1, which is this element. Then it's going to consider arg sub 2, 3, 4, 5, 6, 7, 8, 9. And that's going to work perfectly, right? And so in the place of 10 here, it would be better if we said length of arg. And so length is a function that returns the length of the array that you give it. And you can see here that the array that we're giving it has 10 elements. So this length of arg is going to return the value 10, and the for loop is going to iterate 10 times. Right? So placing length of arg in here ensures that if I add more elements to the array, that the loop will iterate and it will consider each of those elements in the array. Alright, so let's go ahead and run through this for loops. I starts at 0. It's going to consider is arg sub 0 equal to 5, right? Search num. And that's not true. It's not equal to 5. Then it's going to iterate again, and it's going to say is r sub 1 equal to 5. No, it is not. It's going to iterate again, r sub 2 equal to 5. Yes, that is true. R sub 2 is equal to 5. So it's going to come inside the if statement, print out arg sub I, which is 5, and it's going to go into the for loop again, and it's going to iterate. Right? So it's going to basically what this program is doing is just considering each of the elements in the arg array, and if the element is equal to the number 5, it's going to print out the number 5. So let's go ahead and run the program, and you can see here we get 5, 5. There's 2 5s. There's one here. There's one here. So our program works. Right? So what is the time complexity of this algorithm? Well, how many instructions were run in terms of the number of elements n? Right? Well, you can see here that we have 10 elements n. Right? This for loop runs n times, and we perform one instruction, right? We say like if it is equal to a certain value, then we'll print something out, right? And so the time complexity of linear search is n if you're dealing with a one-dimensional array. Okay, and one easy way to figure out what the time complexity of an algorithm is how many nested for loops do you have? Here we have a single for loop that iterates n times. So it should be pretty simple to take a look at it and just say, yes, it has a time complexity of n. Okay. In the next example, we're going to take a look and see an algorithm that has a time complexity of n squared.